Welcome, everyone. Let's give folks an extra minute here to join the webinar. We've got a very interesting webinar for you today, and I see from our attendees we've got folks from all corners of the world, and we're very excited for that. So, good morning, good afternoon, good evening. Some of you late into the evening, so perhaps you'll have a glass of wine or a beer with us, but we'll get started in just a minute. So give us that. I'll meanwhile let you know that a very exciting week here at IWCS. On Friday is our deadline for receiving abstracts. We've had a great response for technical paper abstracts for this year's 75th anniversary conference. So it's going to be a great year for IWCS, and we hope that if you haven't yet submitted your abstract and you wish to share your content, your work, your innovations, and promote your company at IWCS, certainly you have a few more days to enter a very simple abstract. So a little bit more on that later. All right. Well, why don't we go ahead and get started? Again, welcome to each of you joining us today from all over. My name is Dave Cadu. I'm honored to be the CEO and director of IWCS. And today we have Dow to present a very interesting topic that is very important for our industry and for the future of transmission of powering and data. But before we get started, a few housekeeping items. As a attendee, you're part of a larger audience. And with that, during the presentation, all participants will be in listen-only mode. And also, this event is being recorded for rebroadcast. It will be available shortly, linked from our IWCS.org website and also on our YouTube channel. So you can feel free to watch it again or share it with your colleagues. We encourage you to submit written questions at any time during the presentation using the chat panel on the right of your screen. After typing your question in the space at the bottom, please hit the send button, and your questions will be addressed, time permitting, at the end of the presentation. Our webinar series event today is on industry trends. It is hosted by Dow, a partner level sponsor of the IWCS Cable and Connectivity Industry Forum. And IWCS does offer a series of webinars on important trends and technologies from the perspectives of our supply chain leaders and sponsors of our IWCS Industry Forum. So today we welcome three individuals from Dow, Dr. Paul Bagandi, Joanna Giovanoli, and Dr. Yishuan Song of Dow's Wire and Cable business. Paul, Joanna, and Yishuan will be presenting Dow's perspectives on high-performance materials for data center power, fiber, and reliability. Today, the Dow team will explore how advanced materials science is enabling the next generation of resilient, efficient, and sustainable data center infrastructure. And clearly, the convergence of powering and data makes the demands for valued materials and highly developed materials to meet those requirements. So let me introduce Paul. Dr. Paul Bagandi serves as the application technologies leader for Dow's wire and cable business and photovoltaic applications in North America. He's located in Collegeville, Pennsylvania, USA. With over 16 years of experience in the energy and communications cable industry, Paul focuses on key market segments driving the energy transition and digital transformation. Paul actively participates in numerous industry organizations, including the IWCS Symposium Committee, as this year's chair of the 75th Anniversary Cable and Connectivity Industry Forum. So we're honored to have Paul with us. Paul also holds a Bachelor's of Science degree in Chemical Engineering from the University of Delaware and a doctorate degree in Polymer Science and Engineering from Lehigh University. Joanna Giovanelli is a Senior Marketing Manager for the Wire and Cable Market segment in Dow's Packaging and Specialty Plastics business. Joanna started her career at Dow with a Bachelor of Science degree in Chemical Engineering from Michigan Technology University. And over the years, she has held numerous key technology and commercial positions. And thirdly, Dr. Heeshuan Song is currently an Associate Technical Service and Applications Development Scientist for Dow's Wire and Cable business, based again in Collegeville, Pennsylvania. He is an Applications Development Leader for Dow's Wire and Cable Telecom segment. Yishuan holds a bachelor's degree in Chemical Engineering from Tianjin University in China, and then a doctorate degree in Material Science and Engineering from Texas A&M University. So again, we welcome Dow to present today, and take it away, Joanna. I believe you're on mute, so if you want to undo that.
There we go.
Yes. There we go.
So thank you very much, Dave, for this wonderful introduction. We will get started. We are very excited to be here and speaking to everybody today about our materials and our company. We are a global company with $45 billion worth of revenue, and we have various manufacturing sites and research facilities globally in 31 countries. What we get excited about is the collaborative approach to our material science, and that to create the innovative materials that can help transform the world and move us forward. What we strive to do is to have the value growth in best-in-class performance. And how we want to do this is through innovation. You'll hear this throughout our presentation today. Customer centricity, so collaborative approach, and then inclusivity, and we are committed to sustainability as Dow, as an enterprise. We are part of packaging and specialty plastics. As Dave mentioned during my introduction, we are a business unit of Dow. And in this business unit, we have several different strategic segments. We are part of Wire and Cable, where we focus more on custom tailored options for power and telecom sectors. So moving on to Wire and Cable. And the title of our presentation is really about the trends and the drivers in the industry right now. So when we design our products, we want to make sure that we understand those market drivers, we understand those trends. So with sustainability and decarbonization in mind, we focus on safer materials, renewable energy, and options for those type of energies. With our US, especially in the US, our aging and deteriorating infrastructure, we have to provide materials that are more resilient, that will help to upgrade the infrastructure. So for grid hardening, digitalization, this is where data centers come in, and data centers are driving the new grid capacity and the power infrastructure. And then, of course, we can't do it without cost in mind and pricing, right, in mind. So we focus on affordability. The skilled labor shortage is a huge issue in our industry. And then we also take in consideration the regulations and any federal spending that is happening, anything that could help, or something that we have to watch out for. With that in mind, these data came from Energy Information Administration, so EIA, and over the last couple of decades, there has been more or less flat consumption of electricity, right? So energy demand. And this actually is now changing, and there has been several different forecasts. So as you're watching their reports over the last couple of years, there have been much larger growth, much smaller growth. It really all depends on the efficiencies of the technology. So last couple of decades, there's been a long-standing efficiency-driven demand trend. So as the technology improved, right, we had better efficiencies. But now with the data centers emerging, that's a major catalyst for growth for the electricity demand. And now we're talking about more of 1 to 1.6% annually through 2050. So data center electricity could reach about 818 billion kilowatts by 2050. So put that into perspective. It's more than 16 times of what it was in 2020 levels, right? So making data centers that major driver in the industry right now. Some of the hotbeds or the focused areas for regions for data center growth are Virginia and Texas in the United States. But there's many other data centers that are being built throughout the United States and actually globally. So when we're looking at our materials, when we're looking at these market trends, we want to focus on the reliability, on the efficiencies of how we can help the industry, and the data centers will drive the need for more energy. So as Dow, we want to ensure that our materials support those reliability networks and the systems and that we build for lower carbon future. So as our expectations as consumers for speed, reliability, performance continue to rise, the data centers must keep running, right? And to avoid any downtime. So we must innovate, we have to evolve, and you need to have the trusted and lower risk systems overall to maximize the uptime and really reduce that power usage effectiveness in data centers. So we are leaders in material science with over 75 years of experience. We have global technologies, technology centers, Collegeville, Pennsylvania, Shanghai, and then we have exceptional manufacturing facilities all over the globe. We pride ourselves on our global broad portfolio of compounds and products that we offer to this industry. We have really strong relationships with our customers, with third parties, institutions, universities, and then any associations. IWCS is one of them. So developing for this more sustainable future is on our DNA. What I wanted to show here is the depth of our knowledge and expertise. So data centers must maximize the uptime, right? To deliver data computational capabilities. We have to have those strong connections, trusted communications. And to support and improve this power usage effectiveness, the system, therefore the cables also, must be reliable and dependable. We have to be more efficient. So our deep industry knowledge and expertise in this market support our innovation and developments, and then support the needs of the data centers and overall industry, right? So the systems behind these connections, they need to be reliable. Therefore, we have to evolve, right? So this is showing our overall history of where we have been, how we have been developing for over 75 years with many different awards that we've been able to receive for our materials. And at the end of the day, we really need to evolve and build for our future. So throughout the presentation, we will be showing you our product offerings for power cables, for telecom cables, and some of our specialties areas like fire performance. We have offering for all the different parts, polymer parts of the cables. I will turn it over to Paul now to speak about our power innovations.
All right, great. Thanks, Joanna. So yeah, if you go to the next one. So Dal, I mean, for this audience, I mean, hopefully we are bringing in some of our friends in the power world. Dow has had a long-standing history in the utility and power sectors, as well as the communications, which you'll hear about later. And really, our offerings fall into the insulated cable systems, right? Bringing those systems, putting them underground, taking them out of sight, and providing more of a safe, reliable transport of the power, basically from the generation point to the user. And it's becoming ever more apparent this drive and for power is going to continue to amplify as we see data centers come up. So all of these kind of systems need to be integrated together, build out this grid resiliency, and we'll focus in on some of the newer developments that we've got for the power sector here. So anything from even new renewable resources all the way down to the low voltage cables. We'll touch everything in between, particularly the underground transmission and distribution areas. So you can go to the next slide, Joanna. So when we look at our power portfolio, right, we focus in on our endurance type materials. And as I mentioned, we're really going to talk about the entire voltage range, all the way from low voltage up to extra high voltage. And now, really driving even into some of the HVDC applications that are fueling a lot of the subsea transmission of power across countries and continents. So really, when we look at this, again, things that are driving it are the decarbonization, connecting all of the data centers together. As we look at it, electric vehicle charging, uh, this push to higher voltages, newer cable designs, and really more efficient transfer of power. Again, as we look at kind of our role in the sustainable future. So you can go to the next slide, Joanna. Really, what drives um, this performance and this rise to high voltage, extra high voltage, and even within the distribution class, right, is all around the reliability, and it's a function of not only the materials of use, but how they're made and the care that goes into producing the cleanest, most pristine product that we can to enable these materials to now work in these much higher voltages. So all along the way from the time that we start the production of the polymer itself, all the way through the cable conversion, and even in you could say in the installation, there's a huge focus on cleanliness and keeping these materials clean so that there's really little to no points of stress within these cables. And our focus is really on that backward integration from producing the final products that then will get converted all the way back into the production of the polyethylenes or polymers that are used for these different materials. So we are able to control that cleanliness and control that in a closed loop up until to the point that the cable is made. And even there's been great strides to keep cables clean. Okay, so you can go to the next slide. So now we'll just touch on how we're gonna enable, this deployment of these materials for our future. And we're just gonna kind of step through each of the different segments. We're gonna start with the HVDC, right? So these materials are getting more and more attention now. And again, this drive to maximizing power output, right? So we've come up with new solutions that are enabling up to 90 degrees C operating temperatures with very low conductivity and very high breakdown strength. So to really drive the maximum power that you can put through a system, particularly a fully cross-linked system here, that is going to enable these materials to work not only at, high stresses, but higher thermal loads, and maintain their integrity throughout the life of the system. Again, as was kind of shown on the first slide, and is traditional, from an energy cable standpoint, not only energy but also communications, right? We're looking again for reliability. So 40 plus years of field experiences. So really looking to drive that. And so we've got a couple new products on the market in our XLPE installations, the B4401, all the way up to 525 kV. And always continuing to push beyond that, as well as new semicons for a full system, including the B0840 that we show here. This full system here is basically allowing us to maximize power again, while minimizing any risks to the environment and the cost of these really high voltage systems. All right, so you can go to the next slide, Joanna. That's HVDC, right? So we're enabling a lot of these long run submarine applications. Here now we're also implementing new high voltage AC materials, right? So traditional AC materials. And what we're trying to do is enable the industry to put out more cable faster, more reliably, and have more productivity. So as we look to drive decarbonization across the industry, one of the ways we do that is to improve significantly the process that it is to take to make these cables. So significantly reducing the degassing time, right? So when these cables are produced, for anyone not necessarily familiar with the applications, they're peroxide cross-linked, in which case there are byproducts generated. And from that reaction, we're able to use these new materials, and we've significantly reduced the amount of time and energy that it takes to put these cables from the time they're produced to the time they can be shipped by 80%. So you can imagine the amount of savings that you get, not only from an energy standpoint, but also kind of that working capital, moving product out the door faster. And ultimately to the end user, it will be more reliable, knowing what's going out the door, that you're getting in a much shorter time. But at the same time, we're able to run these products longer and longer to try and improve factory output, right? So instead of having to stop and clean up, which is often done for these types of materials, to continue to have very good cleanliness and minimize any disruptions in the cable. Usually the lines have to be cleaned on a periodic basis, say something like every 2 weeks. Here we're able to push that out by doubling the amount of output you need you can have before you need to clean out. So pushing that factory productivity, making longer lengths of cable, and which means less handling, less joints that have to be installed. So much longer lengths of cable can be produced than before. So very significant improvements there. And if you look at it just from a faster degassing standpoint, it, as we said, is going to significantly reduce the amount of time it takes from start of cable production to finish by, more than double, up to 80% shorter times. A lot of that being that degassing process that's done today at for long times and at elevated temperatures, which is where you get the energy and time savings. All right, so we can go to the next slide, Joanna. Okay, so we're going to switch from high voltage, right? So now you're going from the transmission of all the power that's generated down to now the distribution, where we're going to start moving power from that transmission line out to, say, the edge of a data center. And this is really where, in Legacy, we're pushing boundaries to further improve these materials that are designed to last and provide that reliable service to the point of use. We comply or exceed many of the global standards, right? So our focus is on not only meeting the standards, but exceeding them. And you can see a bunch of the different ones that we work with across the globe. So when we talk medium voltage, we talk about tree retardant materials. So you can go to the next slide, Joanna. Then you can build it out. So just this is here, but the evolution of tree retardant materials, this kind of dates back again to the 70s when cross-linked polyethylenes were introduced into the market and were found to prematurely fail. That was associated with water train phenomenon, what was found. So back in the early 80s, the first generation of tree retardant materials was introduced by Union Carbide at the time. And since then, we have continued to improve these materials with a focus on improved processability, improved longevity, and reliability to deliver the most performance that we can get out of these materials to enable that resilient grid. What I want to highlight today is just some of the work that we've done on actually the first generation of materials, but also where we are now with the third generation of materials. So if you go to the next slide, Joanna. This just gives you a high level of water tree. So you can build it a couple more. So again, you can kind of see this water train again, just for real quick for those not familiar, right? This water train is a phenomenon that we see within power cables that are in wet environments, whether they be tree retardant XLPEs or EPRs. And we've continued to improve the performance of these materials as we've gone from that first generation all the way to the third. And you can see how much it's improved relative to the predecessors, which was just standard XLPE. So if you go to the next slide, we had a very unique opportunity to pull some cables out of the ground along the course of 40 years. And this past couple years has marked the 40-year period for tree retardant XLP and EPR cables in the field, where they were designed and expected to, last for 40 years, but nobody really knew what would come of it. And we had this unique opportunity at the Galleria Mall working with Alabama Power. When the first generation of materials were installed around the 1984-85 timeframe, the mall actually opened in 1986. So we were able to remove cables along with the Alabama Power and do some diagnostic testing on these materials. So if you go to the next slide, I think there's one more build and then the next one. We were able to do some breakdown strength measures throughout the course of the field age service of these cables. So when we compare, TRXLPE materials at 17, 25, and 40 years against the same EPR designed cables in those loops at the mall, you can see actually there's a couple just key points, right? One is there's very stable performance across the cable range from 17, 25, and 40 years. And the other being, even after 40 years of aging in the field, these materials are still have breakdown strengths well above the nominal operating stress of the cable design. So that being around just under 60 volts per mil. And you can see we're 3 to 6 times the operating stress is still, even at 40 years, which would signify that these materials have met and are going to be able to exceed that 40-year expectation that the industry had when they were first installed in 1985. All right, so you can go to the next slide. One of the key things that we'd like to highlight, particularly as we start to talk about data center integration, and the drive to more sustainable future and decarbonization. The tree retardant XLP materials do have by far lower dielectric losses from a material standpoint. So that's getting more energy, more efficient transfer of that power from the point A to point B where it's used. So we want to maximize the amount of power that can be generated. And one of the things that we look at here is dielectric losses. So the lower the number, the better. And you can see the significant difference here when you compare the two types of materials. So basically to say, tree retardant XLP has some good opportunity here as we talk about implementation and data center usage and builds. So if you go to the next slide, what this also means is, we can really have an economic impact. So there was some work done actually about 15, 16 years ago, paper that was put out where there was a model of various cable designs with various materials. And if you just look at the impact of those dielectric losses alone across the different types of materials, you can see a very significant difference in the total life cycle cost across the life of cables, depending on the material you choose. So again, depending on how you're looking at a data center build, what you want to, how you want to design it, and as you look ahead and get that more efficient transfer, these types of materials are very suitable and can provide some significant benefit as we look at the sustainable future. All right, so you can go to the next slide. Just again, this shows that was first generation of material back in 1983. That instance was an installation in 85. Since then, we've improved these materials substantially, 5 times longer when we look at the accelerated cable life testing. So laboratory testing on cables, comparing the first generation to the third generation, we're expecting 5 times longer, so much higher reliability factor that we're seeing, project to see with the materials that are actually getting installed today, along with the fact that all of the manufacturing processes for the materials, but also for the cables, have improved dramatically over the years. So key message being, TRXLP does offer a significant opportunity when we look at implementation in data center builds. All right, so you can go to the next slide. The last thing we'll touch on briefly is materials for low voltage cables, so that being the Silink and Unigard portfolios that Joanna mentioned. So you can go to the next slide. Just a few things, right? So the Silink compounds, they offer a broad portfolio across many of the different applications, including, those used in data centers. And then when we look at the Unigard portfolio, the flame retardant compounds used across the power and telecom sectors, which Yishan will talk a little bit more about. So you can go to the next slide. We'll leave you with, and happy to talk about kind of our systems for low voltage being in the moisture curable area with a whole host of combinations that we can tailor different products to different application needs, whether it be, horizontal burn all the way through VW1. We've got the portfolio to support those applications within data centers, as well as, as we look into the renewable areas, including things like photovoltaic installations. And then when we look at across, we know there's multiple ways to put these products together. So Silink offering certain advantages over other methods, but Dow being a wholesale supplier, we have the polyethylenes and other types of functional polymers that we can also support the industry when we look at things like a monocell or cycloplas approach for those familiar. So we're happy to talk about that and collaborate across the range here in the power sector. So with that, I'm going to turn it over to Yishan to give you an overview of the communication products.
All right, great. Thanks, Paul. So we're going to switch gear a bit here to talk about telecom segments. So what we've been saying in the telecom segment is the exponential growth of the connected devices in the recent years, like phones, computers, TVs, and even cars. So I think we're going to see a lot more devices coming, connecting more people, and we need a faster and more data transfers, right, with zero data transfer latencies. So that means we will see continued data intensification and fiber densification, and that's really the driving force that we're seeing in the telecom market. So and not to mention that the larger and larger data centers that's currently being built. So we need to have a renewed look on the materials options that needs to accommodate for this trend, right? Higher fiber density, high fiber count cables, reduced installation cost, and future expansions in the dense networks. So the materials options not only goes into like specialty fiber optic cable jackets, but also the components that goes inside of these cables, internal components like buffer tubes. So Joanna, you can go to the next slide. So this is the schematic of a telecom fiber optic cable network. So the message here is we have the materials options that goes for various applications in building out a fiber optic cable network. So starting from the submarine cable, we have the high quality clean insulation product that goes into this application. And once the data and the cables are onshore feeding the data centers, we have, for example, our Unigard halogen-free flame retardant compounds and our Acceleron jacketing compounds to support the data center indoor-outdoor cable construction, as well as the applications, for example, the interconnect cables. And then for access network cables, for example, microdot cable application, we have, again, our Acceleron specialty fiber optic cable jackets. And I'll touch a bit on this a bit more in the slides later. And for power cable, that's our endurance insulation compounds, like Paul mentioned, used together with our Acceleron jacketing compounds for power cable construction. So next slide, please. So like I've said, our Acceleron telecom cable compounds have the materials options for pretty much all the applications in the telecom space, right, including radio frequency cables, coax cable, copper twisted pair insulation cable insulation compounds, general purpose fiber optic cable jacketing, submarine cable, like we mentioned, hybrid cables, and sometimes we see our Acceleron telecom cable compounds used together with the continuum or continuum bimodal polyethylene resins as a system. So it's a jacket conduit, microdot conduit system. And I'll touch briefly on each of the applications. So for radio frequency cables, for example, we have our Acceleron CX1258. That's a low density polyethylene resin. And sometimes they're used together with K or L3364, which is a high density polyethylene. And together as a system, they provide good electrical properties with low dissipation factors, as well as a good physical properties. Next slide, please. For copper twisted pair cables, again, as an example, our Acceleron CC3485NT, which is a high density foamable insulation compounds. And again, sometimes people use it together with our K or L3364 as a skin layer outside of the foam layer. And as a system, they exhibit good electrical properties, good mechanical strength, as well as good processability. Okay. And for general purpose and fiber optic cable, we have a pretty wide range of product offerings, right? Going from linear low density to all the way to high density to match the insulation method and cable laying environments. So with high density, I'm sure you're aware, with high density, you typically get better abrasion resistance, moisture barrier, and a environmental stress crack resistance. And with low density polyethylene, you get better flexibility and better lower temperature performance. I also want to mention here that we're taking a step to move all of our jacketing compounds towards a non-intentionally added PFAS solution. So it's a more environmental friendly and sustainable solution. We touched on the submarine cable system. So we have product that goes into both the insulation compounds and the jacketing compounds. Right. So for insulation, again, the cleanliness and electrical properties that matters. And for jacketing compounds, because this is outdoor environment, UV resistance matters. And also sometimes for cables that's using using a harsh environment, abrasion resistance also is an important consideration. For hybrid cables, this is the cable design where power and data used in one single cable construction for applications like FTTH wireless cable. It has voltages up to 2 kV and it transmit power to the desired locations. And on top of the materials properties that we talk about, I think for this application, the material that goes into the construction of a hybrid cable, what we're seeing is a long-term reliability of the material also is an important consideration that includes thermal reliability and UV reliability for outdoor application. Next slide. So we talked about the cable design shift and the materials, the new needs on the material side. So we are seeing the fiber densification and the cable miniaturization. You can see the standard fiber optic cable down to mini cable and micro cable. So the diameter of the cable dropped from 17 millimeter down to 2.5, 3 millimeter. And jacket thickness down gauge from 1.5 millimeter down to like 0.25, 0.3 millimeter. And at the same time, we see fiber counts increase dramatically. So what does it mean on the material side, especially for the jackets, right? So the jacket needs to have lower cyclic shrinkage to ensure a high quality of signal transmission quality, right? Lower signal attenuation, lower signal loss, and high toughness, right? For better protection, especially for the thin jacket cable designs. Low coefficient of friction, that's especially useful for microdot jetting cable application. And of course, ease processing with excellent surface appearances, especially when these cables are processed at a higher and higher line speed. So with that in mind, we have developed our DGDA 6321BK for microdot and the specialty fiber optic cable application. So it has the features including low coefficient of friction. So you can see the compared with the conventional jacket, it has less than half of the surface coefficient of friction, which is beneficial for jetting application. It also has low cyclic shrinkage. We mentioned that this is important for signal transmission quality, laser printability to provide a better resolution and a faster printing speed. And also want to mention 6221, this product won the 2024 R&D 100 award. Next slide, please, Joanna. So for laser marking, this is a technique that we have seen has several advantages over the conventional printing technique like inkjet printing or contact printing. So it provides a better, and so it can provide a better printing quality, better resolution, and a finer print. That's especially beneficial for the smaller down-gauged fiber cables. But there's a catch here, right? So then that's conventional black jackets cannot get laser printed because the full carbon black content dissipate the laser energy too fast. So we formulated specialty jacketing compounds, including 6221, and we have a wide range of product offerings going from low density to high density. So these compounds not only provide the laser printability, but also guarantee a comparable outdoor UV resistance compared with the conventional black jackets. Next slide. So Paul mentioned the Unigar flame retardant compounds. Then this is our specialty compounds for indoor application where FR is needed. And it comes as a non-halogenated option and a conventional option, right? So this is the cable compounds that they use in the application where we care about flame propagation and also acid gas, toxic gas generations. Right? For example, in data center, in this enclosed environment and in transit systems, you don't want the flame propagation, but when the flame breaks out, you don't want the acid gas generation that can be damaged to the sophisticated equipments or the passengers. All right, with that, I think I'll pass on to you, Joanna.
All right, so to wrap up our presentation, I wanted to quickly touch on the sustainability and circularity, as it is very near and dear to our hearts. So as Dow, in the interest of time, I'll try to go through this pretty fast. So as Dow, we want to protect the climate, transform the waste, and close the loop. So those are our main topics here. So for what does that mean for our wire and cable business? We design and we develop breakthrough products that Paul talked about, degassing and etc. We have safer materials that Ishan talked about for our Uniguard product, for example, for PFAS-free HFFR type options. We also talk about our post-consumer recycled product that I will introduce here in just 1 minute. And then we offer low carbon feedstock, so biocircular type materials. And then we also focus on our own operations where we strive to have low carbon production. So our Revolup 3215 recycled plastic resins, they are made out of PCR that comes from waste variable composition. And what we do with this, we compound it's 30% recycled material. And you get single inventory management, you have consistency and efficiency for processability, you have that reliability, reliable quality control, and you also lowers the carbon emissions. And what I want to note here, it is comparable and or better performance than our virgin offering at this time. And then finally, to close this out, when we're focusing on our own operations and how do we ensure that we have lower emissions, lower carbon footprint, we are installing a small module nuclear reactor in one of our facilities at Gulf Coast. This will be operation next 5 or so 6 years. It is safe, it is reliable, it is cost competitive, and has that lower carbon footprint. So with that, Dave, I will turn it over to you for questions that we received in the chat. Thank you so much for your attention, and thanks for spending the morning with us.
And thank you to each of you for excellent perspectives on a wide variety of cables, both indoor and outdoor. And I've seen in the questions, the answers are going to be a little bit different for what's the outside cable designs versus the indoor cable designs. So the first question is, since we have an audience today from all over the world, do you see any consistency or perhaps contrasting requirements for either the powering outdoor type cables and also on the indoor telecom cables? So you need to answer, I guess, the question 2 different ways. But is there differences between different regions of the world in the solutions? I see you're all on mute, so whichever one can answer the question.
Yeah. I mean, maybe I'll start. I mean, I think, yes, we do see differences across the world. The thing that we've seen most, if I look from a trend standpoint, I think and if we look at data, maybe we just talk data centers specifically, right? I think we see more of a globalization of the designs in a way, depending on whose data center it is. So yeah, I think you do see somewhat of a trend toward more halogen-free materials. Does it mean it's going to replace anything non-halogen-free? I don't think so. I think you're still going to see both, but I think there definitely is a trend toward more halogen-free type products. I think from I'll talk about the power side briefly, and then Nishan, maybe if he has anything on the communication. So, I mean, from a power standpoint, I think what we're seeing, and I think that's where hopefully we've been able to shed some light on the materials available. I think we're seeing a lot of copy and paste, considering data centers are what I would consider an industrial application. So generally UL requirements, and you see a lot of more EPR type materials used. You know, jacketing, I think you're going to get a mix of materials, probably still just PVC jackets in a lot of those cases, at least for North America. Globally, again, I think you're going to see kind of a shift to some halogen free. But I think the key here is maybe not treating everything equally or just taking what we know and applying it. I think it's time to start thinking about different materials that are available and the given applications and what you're trying to do rather than just a copy paste of what was done. So for example, the true retardant cross-linked polyethylenes can offer some advantages when we look at powering data centers, particularly the amount of power they're going to require, the size of cables that we're going to need. You start to get into cases where that may be advantageous versus the other.
Very good.
Ishan, if anything on the communication side that I missed or different.
No, yeah, I just want to echo on the communication side. I think we have seen like there's a shift towards the non-halogen-free solutions. And I mean, across the regions in North America, we mostly here in the UL riser rating 1666, and in Europe is the CPR, mostly B2C rating for the flame retardant indoor cables for data center construction.
Yeah, and I guess as a direct question on the telecom side, do you notice that for fiber optic and copper network cables used in data centers in the USA, is there any transition from platinum grades to halogen-free grades that you're seeing? You're all on mute, so I don't know who's trying to answer the question.
Yeah, we are getting more and more inquiries about HFFR compounds and HFFR materials for data centers. So that is one of the things that one of the bigger trends that we have noticed and actually came up a little bit quick. So the last 8 months or so that we have been getting a lot more inquiries about HFFR options.
Right, and I assume that the various codes and standards, like the National Electrical Code, is addressing the performance requirements and the safety requirements in data centers. Do you see any changes on that front?
I don't think we see any changes from the specification type requirements. Ishan, anything from performance that you can comment on?
No, I don't think not that I think any changes in the requirement materials performance.
Yeah. And one of the questions is, again, halogen-free versus halogen solutions. In flame retardant wire and cable applications, how much concern is there about the acidity of combustion products? I mean, that's a straightforward halogen versus halogen-free solution question.
Yeah, I mean, again, I think we're seeing at least it varies. I don't think I don't think there's a mass replacement of one for the other, and maybe I've missed, but I haven't seen any regulations per se to say one or the other. It's starting to come down. I think we've seen a massive just swing of trying to see what works, and it's kind of there's a bit of an unknown and how to build these data centers that are evolving so rapidly. So I think both are going to exist. I think the biggest thing we're interested in is collaborating with the value chain and how we can kind of put the best solutions forward for a given case. I mean, as we've seen it's evolving so rapidly, which
Yeah.
is good to
Yeah.
see.
Yeah, so actually Paul touched on one thing. Speed is going to be very important in the data center area. Our customers are telling us that every 6 months or so they'll get different cable designs, and they have to do different testing and proceed with different requirements for those particular designs. So speed is the name of the game right now for data centers.
For sure. Separately, in the immersion cooling data center technology, obviously looking at various different ways for cooling, ethylene glycol, water, any number of solutions. There will be a requirement of low voltage submersible flexible cables. What solutions do you have for such submersible applications? And additionally, it may require NSF certification and potable water compatibility. So do you have sheathing grade solutions for submersible flexible cables?
So I'll let Paul answer that from low voltage technology perspective, but we are doing studies with immersion cooling liquids, fluids. So we know that there's a need. We know that there is an opportunity there potentially. So we have been doing studies over the last year to take a look at exactly that.
Yeah, that is certainly an evolving topic for these types of cables and data centers. Does the polyethylene jacket of the HVDC need to meet the same level of scrutiny in terms of cleanliness as the rest of the compounds?
Generally, no. The jacketing materials do not have the same level, but we by no means discount it. So we go through similar rigor when we talk about quality control and making sure the materials are managed accordingly. But from a kind of when you look at the cleanliness, as I kind of highlighted, the insulation materials, the ones that are at the core are controlled to a much cleaner, or we focus there to make them the most cleanest that they can be. The jacketing's there for protection. So while we maintain a high standard of cleanliness, it's not to the same degree per se as we do for the insulation.
Right. And a two-part question here. What is the flame performance required for data center power cable? And what is the spec or UL requirement for the data center power cables?
Yeah, again, I mean, if you're talking kind of as we're looking more and more, right, from a medium voltage standpoint, I mean, generally they're going to be something like the UL 1072 type requirements. As we get into the lower voltage materials, I mean, you're still going to see, I think there'll be some variations. You'll still see UL 44 type requirements. So yeah, I think it varies a little bit, but I think in general those are some of the things we've seen. There and then we've seen some cases where there's trying to think of the number off the top of my head. I can't remember the exact number, but I think we've seen some things where they're looking at, they're just throwing a few different standards and then one contradicts the other. So I think that's where we've seen there's a little bit of uncertainty in terms of what's needed. It's more of this is you kind of got to start asking the questions, what are you trying to do? And then find the solution that's going to fit it, because they're kind of there's some of these are kind of going outside not necessarily following what's traditional, and they're trying to push the boundaries, but yet just throwing standard numbers around, which may or may not fit.
Right. And, with obviously, heat generation within these cables now, both powering and data, is there an indoor, outdoor material which can also comply with the 85 degrees C 7-day aging test? I think that's where, again, it's a
Yeah.
different solution for indoor and outdoor.
Yeah, I think that is another area that we are looking at. I know we have instances where they have been used. So some of our Unigard flame retardant materials, they are used kind of indoor outdoor. We've again seen kind of a shift in changes in cable design now leading to maybe a change in what those materials need to do, depending on, the fiber densities and sizes of these cables. So it's another area that we're exploring more, and again, want to collaborate, particularly on things like those types of cables where it may be very dependent on a cable design. We're willing to work to assess a given material or make modifications accordingly, um, based on the application. But yeah, certainly that has become another trend that we're working on.
Yep, absolutely. Just time for another question or two. On the sustainability side, does the Rev Loop only come in black? And also, is it able to meet any of the oil resistance specifications?
So the Revolup right now is in black. There's we're in development of other products. So for low density, medium density, high density type polyethylene products. And for oil resistancy, I will have to ask my technical counterparts. I know it meets the same specifications as our virgin material.
Yeah, I mean, I would say it can be, it's black. This version that was shown is black. It can be made natural. We are also always looking at different sources of those materials. I mean, in general, it's going to perform like polyethylene. So you're really not actually going to see much of a difference in terms of the quote unquote performance. Um, kind of in a good way. The design is so they act and feel like 100% virgin polyethylene. The oil resistance, I wouldn't expect to change much at all relative to, I mean, outside of um, the density class of a polyethylene.
Um, Again, just a few more questions. Why is the EPR the installation of choice by most major cable manufacturers in North America for data center medium voltage cables? Flexibility, of course, is an issue. EPR compounds for this application has been in short supply for the past few years. Any comments on that?
Maybe I echo a few of his statements. I think, basically, as I mentioned, I think we've seen as we get a little bit closer to it, it's a bit of copy and paste, which, I guess it's kind of our default go-to in this world of so many options and things. But generally that's what's been used in industrial settings for decades. So obviously it works, but I think we can offer alternative options. You would say yes, EPR is more flexible. However, again, as you start to get into these data centers and see some of the cables that are being designed, I mean, as you start to need more power, you need more larger conductors. So the metal becomes a real driving component of flexibility. So you're starting to lose on that part because you need larger cables, more cables for the data centers and the amount of power. So I think, it opens the door for TRXLP materials. Again, you can take advantage of the lower losses. There's a benefit to considering each of the options, as we look ahead, right? And yeah, there's no reason it cannot be used, right? So TRXLP would be suitable for the application. It's just, I think, a bit of a mind shift.
Yeah. Um, Again, this is maybe a regional question based on code requirements, but what is the flame performance required for data center power cable? I think that's a very general question, but because there may be several solutions.
Yeah, I mean, I think it'd be hard. I don't have one off top of the head, right? I mean, I think
Right.
it's in general, yeah, depending on if it's low voltage or medium voltage, um, and then the region. I mean, it varies widely, but
Yeah.
um, yeah, we could probably take it offline. I mean, but it'll vary. We've seen kind of ask for a variety of different ones.
Yeah, there's so many
And
different
then the cable
factors. Yeah,
designs matter a bit. What kind of
correct.
tapes and things that might be used.
Yeah. And in the powering domain, in a similar vein, we've got, the technologies of fault managed power, the class 4, and UL has a standard, the UL 1400. Um, are there any materials that you have that helps serve this purpose, considering heat mitigation and other performance requirements for fault managed power?
Yeah, I think so. Again, this is going to be a case where, I we have we generally have polyethylene based insulations for those types of materials. Um, you know, it again will depend on the situation. I mean, plenum obviously is more the dominant use there. So, we don't have anything in particular when you talk about plenum side of things, but I mean, it is something that we would be interested in talking about. I mean, I think when you talk things like mixed pairs, um, I guess, and it would be interesting to see if there's any shifts or how things with the fluoropolymers come about. But at the current time, I mean, we certainly conserve um, a lot of the other outside plant, even up to probably even riser. We can probably participate with some of our, insulations, which are thermally stabilized that we can take to higher temperatures. But as you really get into the plenum, I think it's something we'd have to, have a conversation about.
Yeah, it's complex, and obviously this is going to evolve over time, and very unique environments will be discussed, I'm sure. So again, I want to thank you all. That obviously the engagement of the audience is indicative of the fact that this is a very important topic, and how are the evolutions of different types of materials going to help us find the solutions for powering and data, optical fiber and copper, for these applications going forward. Uh, as you can see, you have the contact points for Paul and Joanna and Yishuan if you want to reach out to them directly and answer more specific questions that you might have. Again, I want to thank Dow for taking the time to share this information and the complexity of it all. And also, please make note that our next IWCS technical presentation webinar will be on May 15th. We typically produce these on the third Friday of every month at 10:30 a.m. Eastern USA time. So each of you will be receiving a notification and announcements for these events. And please feel free to share those announcements with your colleagues so that they can join in as well. I do want to remind you, of course, that this Friday is the deadline for submitting your technical abstracts. Like the work that Dow has been accomplishing and you all are developing for our industry in these complex solutions, please present these to the IWCS audience and get recognition for your work and for your company's contribution to our future. So please submit an abstract. It's a very simple process for a one-page abstract, and then it will be considered for inclusion in the program for the conference in November. Before we leave, I do want to make sure we recognize, of course, Dow and our other partner sponsors for IWCS. Without their support and generosity, we wouldn't be able to bring this excellent content and technical innovations to you and our global audience. So we thank these partner sponsors for IWCS. And again, I hope that you'll be making plans to join us in Orlando at the Gaylord Palms, a great venue, the first week in November for our 75th anniversary of IWCS. So we're going to have some fun celebrations to recognize that amazing event. And of course, bring your family. There's a lot of new attractions at Disney and Universal and around town, so that it might be worth having you and your family join us as well for this amazing event taking place in early November. So again, we want to thank you for being with us today and look forward to having you participate with us in our upcoming webinars as well as in Orlando. So thanks very much to the Dow team and have a great rest of your day.
Thank you.
Thank you.
Thank you.
Thank you.